I won't need to introduce myself too much, but as my career has been very much about dairy cow monitoring over the past 40 years, the sort of developments that I've seen are really part of my life history as much as anything else. So I'm going to share the screen now. And okay, so you should now see my very nice picture that my partner took a couple of years ago. So no need to introduce myself, except lots of stuff. So we want next one. Okay, so what I was going to talk about tonight was a little bit of my history, a little bit more about the stages in agricultural history, how we've gone. Even in my lifetime, I remember milking cows by hand in Scotland in the 1970s, to robot milking systems, a bit like that old thing, Adolf Hitler, my part in his downfall. So that's it. I had a small part in these things. Rumen telemetry, very much one of my own, but again, I was asked to do that at the Institute, and progesterone sensing. And some of you may not have heard of VirtualVet, but we'll follow up. But what I also like to talk about is how commercialization of research can work. It doesn't always work, but there are some pitfalls that I've managed to not fall too deeply into. So I started, well, I actually left school at 16 and worked my way up to being a herdsman. And this was a picture on the front page of the West Somerset Free Press, where someone who was milking cows had got a degree in engineering. So they came around and photographed me. And I think the cow understood more of that book than I did, but never mind, that's what newspapers about. My final year dissertation in the Open University was the commercialization potential of goats. And I and my late wife started a goat farm in the late 80s, early 90s, and built it up to be quite a commercial success. So when the Institute came along and said, we need an engineer who knows a bit about cows, I was right in there. And this from 1988, 99, when I joined the Institute, is the sketch I made of what a robot might look like. And given that no one knew what a robot would really look like at those days, we were still trying to put things on by hand. But yeah, and 20 years later, or even 25 years later, when DeLaval celebrated their 20th year in production, they dug this sketch up, and I was quite shocked when I was at a show in Italy, and this was the first slide up saying, this is where it all started. And I thought, that's a bit of history. So on we go. Yeah, so I think it's worth taking the long view, and that's always a benefit. When you get older, you do begin to take a long view. For 12,000 years, people got around without any science. There was no technology, and everything was done by hand, and human labor, and a bit of animal labor as well, of course, once they domesticated horses and cattle. But also all the control came from humans. And that's something that we have to start thinking about now as we replace it in what we'll come to in a minute. And then if you like the heroic age of agricultural science, 1750 onwards, where people began to apply a bit of science, and we started having institutions like the Rothamsted Institute or the Royal Agricultural College, founded in 1848. I was privileged enough to have 5 years as a professor there, and it is a privilege. It's not one of the leading institutions, I have to say, in terms of science, but it's certainly a very famous institution, and turns out a lot of very good science, a lot of very good farmers. And then, of course, metal implements come in, huge population growth. All the fertilization was being done by recycling, or what they now call regenerative farming. And I put this one in because I did see people horse ploughing, not just in competitions, but in Devon, where I grew up, people were still using horses in the 60s to haul and cart, and occasionally you'd see somebody ploughing with them. But then a few years ago, I was in Cuba, and this is how things work in a communist society. There's still oxen pulling ploughs. So it's not a continuum of technology. And then the 20th century is very much what you might call third phase, 100 years, powered machinery, artificial fertilizer. a lot more science in plant and animal breeding, electrification, huge population growth, something like 3 billion people now extra alive than could be sustained with organic systems. But we've got this downside of environmental damage and the toxic nature of some of the things that we've done to soils and to water. So to me, agriculture 4 is what we're on now. And I remember Professor Schön, I don't know, some of you must remember a presentation he gave at the 1990 IAgrE conference in Berlin. And he said, we've had these fantastic improvements in productivity by applying power. One person can move hundreds of bales where it used to be like 10 people. That phase is over. Now we can do all this new stuff. And he was well ahead of his time. It's a pity he died 3 or 4 years later and never actually had a chance to take it through. So farmers are very much now, and especially with the ELM scheme coming in, they have to be seen as more environmental managers within a supply chain. But I know a lot of farmers don't like it. They're no longer really independent traders. I know that when I got my goat farm, we were able to develop it because we had a supply contract to a company that made cheese, but they set the specification, they set how much we were going to provide. You know, the idea that you sort of roll into market and you get the top of the market price, which still some people like to live in that fantasy world, it's not like that anymore. So everything has a data trail these days. So let's have a quick look at robotic milking. But our first prototype was in 1989. I designed the special building at the Chesteridge farm at Compton at the Institute for Animal Health for us to house that. So that's, if you like, my first was, I'd actually designed the first robot milking barn in the UK. And the Institute had a good deal and sold that system to DeLaval. And they spent 3 years with several of our staff over there. Mike Street was the main man. And DeLaval launched their VMS in '97. And then, so you can see, I think, the very first prototype, not so different from what we'd anticipated. So now robot milking is still only about 5% of the global cows being milked. Well, sorry, in, let's say, developed world systems where there's about 300 million cows being milked on about 1 million farms, there's only about 75,000 operational robots. The rest are still being milked on rotary parlors, and parlors that have been around for a very long time. But there is steady growth. There's new factories being built in Sweden, Germany, UK, Netherlands, etc. So I was at the Precision Ag conference in 96. When was the year of the referendum? 2016. And these 3 guys from DeLaval came and had to take selfies with me because they said, you invented this stuff and we wouldn't have jobs without that, and we're selling like crazy. So yeah, it is coming, but 20 years of development. So the robots have got reliable, milk quality sensing has improved a lot. The teat cleaning, which no one's got the same system. Everybody's doing it a little bit differently, but it is a routine now. That was one of the bits that we didn't have when we sold it to DeLaval. The herd management has improved and the building management is much better. Cows are standing on rubber mats. They're not getting as lame as they used to. The bedding is much better managed. Whether that's because there's more release of labor, it's hard to say, although you can still go to really disgusting farms where the cows are clearly not being well looked after. But overall, herd management has improved. And partly it's because the the buying schemes like Arla and Arla Garden, they're very insistent on farm inspections and on quality management all the way down the chain. And what they get away with, of course, is they buy milk on the open pool. So not all the farms are up to the standard, but the ones on their routine contracts are. So that tends to be what drives the market. You get an extra penny a litre if you have certain technologies on the farm. So with the robotic milking, one of the surprises that we had was that the cows became calmer. That we were worried that if the cows were never meeting humans, they'd all get a bit wild and, you know, run away. It's quite the reverse. The cows get very relaxed and come up, and you can barely move through them now because they all want to sort of rub up against you and kiss you and all the rest of it. We've certainly saved labour, and that's good, and you've increased the amount of milk per cow because they're being milked on average 2.7 milkings a day. I do love statisticians a lot because like we had 16 cows back in 92 when we were doing our testing, how many milkings a day, and we got 2.7 milkings a day. And about 10 years later, I heard a statistician say he'd analysed 2 million milkings and the average was 2.7 milkings a day. Brilliant. Yeah, so there's nice modular growth. So people are tending to expand their herds in blocks of 60 cows. As they put on more cows, they put in another robot. The one thing we still haven't cracked and no one's really got to, there are people who try it, you know, having the cows move through the robot, is there's no grazing going on, which means it's not great fitting into some of the future systems that people want. No one's saying anything, so I'm hoping I'm not going too fast or too slow. Okay, so now you've got all the major manufacturers have got themselves. DeLaval, of course, have been around 100 and something years. IAgrE have been around a long time. That's a forward. They've been around since this. Robotic is a US-based company. They all have slightly different ways of getting the cows in and out. Lely were the ones who came from almost nowhere, from the Cornelius van der Lely with his inventions, and they are now probably market leaders in most markets, with DeLaval a close second. But the selling points for the robots now tend to be around service facility and how nice the local dealership is and stuff like that, rather than, you know, they all milk cows very well and they all do the job. And they are a superb platform for adding sensors to. We can come on to some of those, but when the cow's static there, in the Lely and one of the others, they take the weights that cow's putting on each foot so they can do lameness detection. They're scanning over the back to see the fitness of the cow, and there's a whole lot of extra technologies that are still in the pipeline. So when we got the robots up and running, the first thing that I realized we had to do was we had to start sensing things, because when you're milking cows, you're watching them all the time. You know, you can do most of the routine work of washing cows, putting teacups on, all that. It's almost like you do it almost with your eyes shut, but it's the actual monitoring of the cows, their health, their fertility. So you begin to, as an engineer, to start saying, what kind of sensors have we got? And we haven't actually got any direct sensors for the things that we really need. So we're always doing a proxy measurement, temperature. You can do some physics with conductivity. We can do some chemical sensing, pH. You'll hear a lot more about that as I go on to the next thing. Glucose you can monitor chemically. And in the recent past 20 years, certainly 10 years, and in the past 2 years, we've got into biological sensing, where you can set up an antibody which will capture hormones or disease markers. So with COVID, it's you're looking at the antigens. But when I was started in this, we ended up setting up the first biosensing lab in SRI, and I was very glad to be able to recruit 2 or 3 key people. Will Ditcham came for a while from Institute for Animal Health, and then there was Maria Velasco and Claire Turner, and we put together a very good team, and it's just a pity that that team had to break up with the Institute. So one of the key things that happened in the past 20 years was not so much the invention of the mobile phone, although that's a really important thing, but because suddenly silicon-based sensors could be made really, really cheaply. So the tri-axial accelerometer, I mean, we had sort of counters and things like that before, which were fairly heavy, expensive things, but suddenly you can start buying a tri-axial accelerometer for about $1 a time. And so after 2002, they became incredibly cheap. And you can measure movement with those. And this was one of the first pieces of work I did. Actually, I think it was about 2001. We were using a very, very basic system. And you're measuring 3 axes of gravity, of the acceleration due to gravity. And you can use dear old trigonometry to work out, you know, the cow's got a collar at an angle. You can tell when she's turning left and right, and so on. And so by lots of data analysis, you can work from movements to behaviors. The main use of these systems is for estrus, for breeding, but you can also measure eating behavior and lameness. And we did some really interesting work with if you take the sum of squares of all this lot, you can actually see the accelerations due to the cows propelling themselves forward. And then if you see an asymmetry, a cow is propelled, the front legs are effectively just a prop, but she actually pushes herself forward with the hind legs. So if you see an asymmetry, so that one acceleration is faster than the other, you can almost certainly tell that she's got a lameness developing in her hind legs. But the other thing we found was that the quickest way to detect a lameness is actually to measure the time it takes a cow to walk from A to B, which is blindingly obvious once you've done it. But mostly because cows get pushed around a lot by humans, that tends to get masked by that behavior. But the slower a cow walks, it's usually because she doesn't like walking very much. So that if I go back, tri-axial accelerometers. After I left Silso, the Monday after I left Silso, I was started work as a program manager for Scottish Enterprise, and they wanted to accelerate growth of companies in Scotland. And so they came in and said, right, you've got £6 million, you've got to spend it in the next 3 years. Oh, and by the way, you've got to spend £500,000 in the next 3 months. And basically what they wanted us to do was to go and get companies to develop a collar system to measure cow movements and estrus and so forth. I had mixed feelings about how that project went, because I knew there was something better that we'd been working on at Silso. But as it ended up with Strathclyde University spin out called Silent Herdsman came out of that project, and that was eventually sold to the Israeli company AFI. So that wasn't a total waste of £6 million, but I do feel at times we could have just driven around Scotland throwing bundles of notes out of the car. Would have been just as good a way of getting businesses to start up. So I got a bit fed up in giving other people money to fail. So I started my own, see if I could do better. And that was in 2007. And the first thing we designed was a collar for the tri-axial sensing, which was the project that I'd been leading at Scottish Enterprise, because no one seemed to be able to make a collar design that actually worked. But I could see there were plenty of other companies moving into that space, and I never liked doing things other people are doing. But what I had done at Silso was Pfizer had come to us and said, can you measure the pH inside a cow? And so the lads in the electronics group and I sort of hunted around, and we ended up with a rumen telemetry system that sort of worked. We had some problems with it, and one of those I spotted. The Silso tried to start a company called WellCow, but you've really got to have a lot of energy to make a startup, and it kind of faded away. And in the end, I just got a letter from them saying, yeah, you can go off and do your own thing. And so I took some of the ideas and patented my idea, and that worked. And the key simple thing was, if you're using a pH sensor, I must have some kicking around somewhere. I've got plenty. Yeah, here's one. Sorry, this is on my bench here. I'm just still doing some development work. Okay, so back to humans. So if this is a pH sensor, it's a very simple piece of electronics, really. The clever bit is the glass bulb, which is specially formulated glass, which will allow hydronium ions to pass through. So there's a sensor in there that measures that. But the reference electrode is actually sitting all the way up the top here, which is a silver chloride electrode. And there's what they call a frit, a wet junction, so that you've got a flow of electrons between the two, so that you can then measure that differential between what you're measuring there and what you're measuring there. And the simple trick that I made these things work, because if you put them in and they go upside down, in laboratory practice or in an engineering plant, they never go upside down because you're always dipping them in because liquid gravity, etc., etc. They're always that way up. But when you put them inside a cow and they're going upside down, what happens is you've suddenly got gravity trying to get the rumen liquor to go through to the reference electrode, which then means that you're not measuring a differential at all. And you've also got the air, which is in these barriers, bubbling its way out steadily. So if you let the things go upside down, they die within a few hours. But if you can keep them that way up, they keep on going. So my invention, such as it is, was just to make sure that you put a weighted end cap so that would always tended to stay at the bottom of the rumen. Very simple thing. And the other thing I did in the same patent was just because everybody who had previously worked on things like that would put, what do they call them? A reed switch. So you could have a magnet on the side of your bolus, and then when you took it away, it switches it on. And if you applied the magnets back, it switched it back. Well, I didn't like that. So what we did was we just measured the temperature. So when the temperature goes above 32 degrees C, which either it's on your lab bench on a heater or it's inside a cow, it switches on. So very simple patent, which one of my proudest achievements was to have written the patent and get it granted. Surprisingly simple patent. So we started the company. We had a few difficulties. We had a few difficulties. We raised a bit more money, mostly from grants. They'd paid me stupid money at Scottish Enterprise, so I had plenty of savings to get started with. And by 2016, we'd been through a few bumpy rides, but we had 6 employees, very good technical people. And we were living by our sales for the past 4 years. And I was able to sell the company last year with a different story there. Yeah, because in 2020, because most of our customers were research people, they always work in pairs, which meant that when lockdowns came around the world, they just couldn't work. They couldn't do large animal work. So I had nothing to do in 2020. And so I just redesigned the bolus to make it smaller and to have a longer radio range. The limitation we'd had with our system, which was based on 433 megahertz radio, relatively short range. But so I sold the company as a going concern. In fact, I'm down at Dairy Tech tomorrow to meet the guys who bought it because they still want me to do occasional bits and pieces for them. So yeah, we developed that because we kept being told acidosis is a big problem in cows. You feed them the wrong stuff. So we were asked if we could measure it. Yes, we did. We developed the system to read it through from the outside. And we started off with a tablet type platform, and then this mobile phone came in. So we then had to redesign everything around Android, which was a very expensive business. Yeah, so this was where we went with it. There's a bit of the cow that's called the reticulorumen, and you can tell from the Latin it retains things because whenever they do pathology on a cow, they always find that part of the rumen full of stones, and nowadays nuts and bolts, beer cans, chopped up wires, all sorts of bad things end up down there. But it does mean that there's a lot of things that you can pop into a cow which will just stay there. They use it for slow drug releases, things like that. But for us, it was great. We could pop the bolus in down the cow's throat and it would just stay in the cow forever. I think we've only ever had one come back, and that was from a slaughterhouse that found it and said, "What is this thing?" and posted it back to us. So we collected pH and temperature. We downloaded that onto a smartphone, for which we had to write the software. And then the handset is a perfect vehicle for uploading data to the internet. Unfortunately, you can't make a bolus last forever. The pH sensor eventually gets poisoned, so you end up with a pH 7 value almost permanently, which means it's failed. And if you put 3 or 4 of those in a group of cows, you can monitor pretty well what the cows are eating. The data goes up and down. When they eat, there's a pH drop, and when they're not eating, there's a pH rises. What we did find over the years was that the definition of acidosis, which used to be given by vets as extended periods of low pH, well, that's all qualitative. Where's the numbers? We now are able, well, we didn't particularly do the work, but the French INRA did the work and showed that actually if you've got a pH range of 1, that tends to be that the cow's bacteria that digest starch are dying off at one phase when it's up here, and the bacteria that like fiber are dying off when it's down here when the pH is low. So we've now got a numerical definition of rumen acidosis, which that's a nice feeling I've got, that we can rewrite a veterinary textbook. So in 2020, this is the way we were making them, which was a sort of a to get the size right down. We had a molding process, and this is the sort of final batch. So it's a bit like a boat gel coat. So that the inner bit is the resin mold, but this one you put on a gel coat and it just drips off the other direction. So that was my final batch, and I kept selling those for about 6 months until we ran out and I'd got the new one designed. Okay, so the achievement that I feel best was we actually survived for 13 years as an independent company. We rewrote the textbook on the definition of what SARA is, and we digitized what had previously been a sort of, oh, she's looking a bit sick, she must have acidosis. We've actually turned that into a numerical definition. And we sold it as a going concern with 4 years of profits on the books. So I feel fairly chuffed about that. It doesn't mean I made much money out of it, but it's a nice feeling to be able to walk away without being bankrupted. So then I moved on into the other project I've been doing at Silso was how do we improve fertility management? I remember our DEFRA commissioning officer, David Garwis, I'm sure some of you may remember David Garwis, saying, Toby, you've got to do something about fertility management in dairy cows. And it was like a mission from the boss, get on with it. And it's taken about 25 years, but we've got there in the end. I mean, collars, which have been around for a long time, they'll only get about 70% of estrus because some cows just do not exhibit the signs. In fact, the modern cows tend to be less active than previous cows. They partition their energy into producing milk, not running around jumping on each other. The other thing in fertility management is that pregnancy detection is still done either with ultrasound or rectal inspection, and that has its own issues, and it's an expense, and it's an intervention which could be causing some loss of pregnancies. But we know there's a measurable cycle of fertility hormones, and the gold standard of that is progesterone measurement. And we've known that for 30 years, and I saw all these different, we reviewed all this stuff in the late 90s, cameras, collars, and everything was tested against progesterone. So we said, why don't we just put that in a box? Well, we had a good go at it at Silso, using electrochemistry rather than the optical systems that we have now. And that kind of worked, but it would always have been expensive. And then, of course, the Institute closed, so that project sort of died with the Institute. But I was always keen to revive that because it's still, that mission to do something about dairy cow fertility. So by 2016, I had a company that was ticking over, selling boluses, and I had a very good technical team, and they were sort of chomping at the bit to do something else rather than just keep improving what we had already. So in 2016, I filed a patent on making a cassette of lateral flow devices, which took a bit of selling to other people because, what's a lateral flow device? No, why don't you do it with magic? And I said, we've tried all the magic ones, but the one that works is a lateral flow device, because there was a company by then selling a dipstick technology to measure progesterone in milk with a color change. So over the next 4 years, I raised 1.6 million in equity and grants and loans. We demonstrated a prototype, but in 2019, the investors who had come in on a tax scheme suddenly decided that they'd pull all their $500,000 out. So suddenly we were running out of money, and we were very lucky to be able to sell as a going concern to Lely Robotics in 2020. That, to me, is a tragedy, is that they've not really taken it forward, and they've been beaten to the fence, as it were, by DeLaval, who have a system almost identical to the one that I patented in 2016, with a patent that was 8 months later with just enough difference that they couldn't be stopped with it, but I still feel we beat them to the post on that one. So yeah, so that was our first prototype, 2016. We knew that if you pulled the sensor out of this nice tube, dabbed some milk on it, and then read it with a little camera, you had a system. That was pretty cumbersome, but it got us the investment. Later on, we started making cassettes like this with lots of lateral flow testing, and this was all made at a factory in Derby, where they had this fantastic piece of thermoforming that this barrel rotated and formed. One of the key things, and you'll know because you've all used lateral flow tests, you've got to keep them dry. So at the top of the cassette, we had a little pill of what they call it's a drying agent. So that's the key, one of the key parts. So we went right through the whole process and ended up demonstrating our system at the dairy show in 2019 on the robots at the gear robots they had at the farm in Somerset. And then the next year, DeLaval, the Lely company came along, made a lot of fuss, took me out to lunch many times, offered me loads of royalties, and then took over, and haven't really done much with it since. But my feeling is the mission is over. We know that progesterone works, and DeLaval launched their system 2019, which is probably why Lely bought us, because we definitely had technology that was competitive. It'll automatically do pregnancy. It'll detect the abnormal cycles. It'll notify the farmer if there's early abort. All of that stuff we were doing. So that's it. So my feeling is progesterone is done. Someone's got something on the market, and the others will follow, because that will put the rest of them, the collars will become history. So that was a story. One of the things you do when you've got a company is you're always on the lookout for money. And in 2014-15, we were desperately short of cash, but we did have programming teams who could work in Android. And so I was at an EU meeting and met a lady called Sinead Quealy, and we put together a project to make an app, because the money from the EU was to develop some apps, be like the Americans, have lots of apps. So we developed an app to record antimicrobials. And you could press a few buttons and record all the things you were treating cows with, which is actually a legal requirement, and sheep, of course. And the clever bit that we put in was that you could just take a photograph of the ear tag and take a photograph of the box of pharmaceuticals, and then that automated the process of creating the mandatory requirement, which is to have a remedy book. And that saved the farmers a lot of effort, except they didn't use it. So the bit they did use was WhatsApp to take a picture of the ear tag and to take a picture of the pharmaceutical pot. So we slowly abandoned the app, but we did continue to develop the company, and we started with a EU grant. We've developed quite a major database in Ireland. There's about 3,000 different pharmaceuticals used on farms, which need to be reported when they're used, and the drug companies are constantly modifying and changing them. They have different withdrawal periods and so on. In the end, we became a supporting contract for Board Beer, which is the Irish Marketing Board, because they get asked a question: what's the PCUs you've got on your farm in Ireland from the people who are selling cheese in Germany? Same with AB Foods. They want to know what's happening on the farms. This is the integrated supply chain. We ended up with 4 employees, but at the moment we've now got Sinead's decided that she wants to move on, and we also had problems. The investors suddenly turned around and said, I only invested because of the tax benefits, I want my money back. So suddenly you find the rug comes out from under your little business. So we're now just transferring the IP to Board Beer. They'll be running their database, will basically run on our code that we wrote in 2015. And we're converting ourselves to just doing consultancy because it pays better. So our staff are redeploying themselves to Board Beer in effect, because Board Beer need the employees to do that work. So sometimes you just run out of energy for running a startup. So my experience with startups is what you need is motivated individuals. It doesn't work having institutions say, oh, we'll have a startup. You can't tell someone to become an entrepreneur. It doesn't work. You need a long-term vision. You need to be thinking 10 years ahead, which is why I'm giving it up, because, you know, I hope I've got more than 10 years, but you have to be thinking you're still going to be very active in 10 years. You need to endure quite tough stuff. And you really need investors who are committed to the business. Too many of these tax schemes, they're just there for people who've got some cash in the bank to say, oh yeah, I can put it in there and I get all my tax. No, I don't have to pay tax on it. But then they want their money back before you've actually got to the stage that you need to get to. And I always say now and I do quite a bit of mentoring now, is you need early stage customers. And there are farmers, about 2% of them, who will go out and look for new technology. So if you can find those guys, you can do some amazing things. So let me just move on. I can't remember what I've got now. So the areas that I see the next generation of startups and new technology will be in the things like I was talking about back. It's water quality management. We're going to have this. I wrote this slide before the price of fertilizers shot through the roof, but we need less nitrates for the sake of the water environment, not because of anything else. And we need to use less phosphorus, which is, that can be a bit more of recycling can go on in the human waste process, but we're not going, there aren't infinite supplies of phosphorus. And the soil health, and I'm sorry for people who are dedicated to the plough, but no tillage seems to be the way forward. One of the things I've done in the past few years was to manage DEFRA's greenhouse gas projects. And it's clear to me that nitrous oxide emissions and ammonia are one of the biggest problems. And if we want to have a more balanced cycle, we'll have to have much less tillage. I mean, the reason for ploughing in the old rotations was that's your way of using the fertility that's built up over the grazing or fallow period. We can't really afford that with the population we're carrying. So to me, that is something that the engineers, obviously there are all sorts of systems out there, but we're also going to have to use a lot less weed killer. So that's that to me is some of the big changes that are coming through. And so the new challenges are zero carbon, which to me it's pie in the sky for farming, to be quite honest. I've seen so many people claim this, that, and the other is going to be zero carbon, and I don't see it coming yet. We can sequester a lot of carbon, but we also need to harvest it as well as crop. We'll go over to all electricity. That's a very interesting challenge. Getting rid of diesel and heavy engines moving across fields. I was at the FERA conference in France, where all the new robots are coming through, which are all autonomous. They're nearly all electric driven. Some of them have a charging diesel engine somewhere to charge them up, but they are saying they're running 24 hours now on all electric with a recharging station at the end of the field. Climate change, obviously, big one for all of us. Fewer staff available. I mean, I know there's sudden, we've got a few migrants coming from Ukraine all of a sudden, but that's not going to solve the problems in the long term. In the long run, people don't want to work in agriculture. Rewilding seems to be a big thing, although anybody who talks about rewilding as a new thing hasn't walked around the north of Scotland, where there's huge numbers of empty farms and places that are now just forest returning. And even if you go up into the Welsh hills, I can remember when you'd walk everywhere on short grass cropped by sheep. Now it's all scrub and trees and goodness knows what. So it's been going on a long time, and it's going to keep on going. And also we need to reduce the antibiotics that we use in livestock, which is becoming an issue in human health. So that's my quick roundup of the new challenges. That's me. Yeah. So what I like to say is I've been surfing this wave of innovation. It is a revolution, and it's just great to just dive into it. It's fun, it's exciting, it's life-affirming. It is dangerous financially, I have to say. I'm lucky not to have gone bust a couple of times, but it's also very satisfying to look back and see how far we've come, and also forward to see some of the new things that are coming through, which I'm really keen to be involved in. So, gentlemen, that's my hour of gassing away. So you've been incredibly patient, unless you're all sort of gone to sleep. So over back to you, John.
Well, thank you very much indeed, Toby. It was really interesting, and I was watching the chat and seeing no questions coming up at all. So that means either everyone was asleep or everyone was finding it so fascinating, and you explained it so well that we haven't got questions. But there is one question there now. If I could just start off with one. I recall in the early 90s, we were looking at possible technologies for estrus detection. And you were talking about using a tri-axial accelerometer for measuring estrus. Not quite sure how that works. Can you explain?
Right. Okay. Let me explain by putting if you're familiar with a smartphone, at the top you've got a little rotation. Oh yeah. Now that's all detected by using a tri-axial accelerometer. Yeah, I know that. So if your cow's head goes down, you've got a change in the gravitational effect. It's a cosine of the angles, that type of thing. And so by the number of movements she makes, you can count those movements, and they increase in a cow with estrus. They also increase at feeding time, and there's a famous patent, guy's got a Russian name, but he works for AFI, Voronin patent, and that's all about filtering out cow movements that are related to eating from cow movements that are related to running around because they're on estrus. So that's really, I mean, estrus detection was being done by little rolling balls inside a raceway, and that used to just click every time they went in, and that was counting steps. They were mounted on the cow's leg usually, so you were just counting steps. And so we've replaced that with the much more sophisticated 3-axis accelerometer, the sort of thing you've got on your phone. It tells you how many steps you've taken. And when you get usually it's an integer factor increase on a number of steps a cow takes in a day. So that's how the estrus detection works. Okay, but you were saying that it's only 70% effective. Yeah, because a lot of cows don't walk around enough, and that people send the peaks out. Some people claim, oh, we're getting 75%. Well, great, but that's not 100%. Whereas progesterone will get you something like 97, 98%. Yeah. Because all the cows have that cycle. Yeah. Okay. Thank you. There's one question from Tim R.
Tim Reynolds.
Tim, would you like to put your question?
Yeah. Toby, how trivial is it to develop these apps? As aquaculture engineers, it seems to be quite the domain of computer scientists. Is this true, or were you able to actually develop apps quite simply once you actually got your head around them?
Okay, well, I'll have to say we always focused on the Android phones. Yeah. The vets, they buy iPhones, but the farmers have Android phones. Yeah. And also, Android operates on an open source. It's a Google product, and you can put an app together to go into the Google App Store for a few weeks' work writing in Java usually to write an app. It all depends on how complex your app is. An app's usually linked to databases, and it tends to be the database side which takes the heavier lifting in terms of the software development. What I would say though is the biggest challenge is, you write your app and it's great and it works and you can knock it out in a few weeks, and then Google changed some of the fundamentals in the Android, and you have to so basically you end up with an expensive member of staff who's just there to keeping up with the changes that are coming through and the new styling. Oh, it's looking a bit old-fashioned. We've got to get a new app done. But for example, some of the basics on the app, I did do a bit of Java programming, but basically, if you look after the framework, you go to an agency like Upwork, which is just a computer as far as I can see. I'm sure there's people somewhere in it, but you put your requirements online, and suddenly you'll get half a dozen people from all over the world who'll do it, and you get them to ensure you make sure that they do what you want by having a very tight specification on what the outcome's going to be, and for literally hundreds of pounds, you can get stuff written by, I think the first one that we got written for our Android one was written by a guy in Serbia. you know, and heat for sort of a couple £100. I've had people in India do it, people in Pakistan. I don't care where they are, as long as the software meets the spec. And for someone in India, a couple £100 is a month's salary. You know? So you don't have to write the code yourself. Nowadays, there's code stores like Codex, which claim that you can more or less write natural language what you want the program to do, and it will interpret it into code. But I don't know anybody who's built anything big like that.
Okay, thank you very much. Dave Tinker's put a question in. I don't know, Dave, do you want me to read it as you're feeling a bit hoarse? Yeah. Plenty of new ideas coming along, possibly even better joining up. Oops, it slipped. Possibly even better of ideas from, sorry. Plenty of new ideas coming along, possibly even better joining up of ideas from dairying to transfer to environmental arable aspects. Will this really get going, or is it still going to depend on a major company, like an Apple of the ag world, to get really good take-up?
Oh, that's a very complicated question. How long have we got? I mean, the people who really, I have to admit, I admire most are the very progressive farmers, and I've been lucky enough to work with a few of them over the years. And you know, there's a big thing about, oh, we don't like big farmers, but they generally have got big because they're very good at what they do, not just, and they often are looking dynastically. You know, I know that one or two have said, well, if the kids didn't want to farm, I'd be giving it up because it's too hard. So, you know, so they are thinking long term, and they're planting woods, and they're well ahead of the game. Someone like Neil Baker with a couple of thousand cows, you know, he's a very environmentally friendly guy in the sense that he's got solar farm up one end of the farm, and he's got this anaerobic digester. So some of the inventions that we think are important are only going to work at scale. I mean, regenerative farming is basically mixed farming, but at a bigger scale than one man and a dog, basically. I mean, this is part of the issues that we've all had through the past 50 years. I mean, I can remember starting work on farms where we had 7 or 8 men. You go back to the same farm, there'll be one and a half, and maybe a contractor sometimes. You know, that's diminished the ability to have different enterprises on the farm. So you need that mix of livestock, arable, woodland, to have the sort of regenerative stuff that people want, and the what do they call it? The circular economy. That's the other buzzword. So my view is that I don't think that the big companies see enough money in farming. That's the thing. So I don't think there's a sort of global company that's going to come along. And if they do, if you do see a global company, it's probably because they're buying something cheap and flogging it to farmers expensively. You know, most pharmaceuticals are pretty cheap to manufacture, and once they're out of patent, you know, they spend more money on marketing to make sure that the cheap alternative doesn't come in and take their market, rather than new product development. So I'm not a great fan of big companies, but I am a fan of big farmers who know what they're doing. I don't know if that answers your question at all, then. No magic solutions. No magic solutions is my motto.
Yeah. No, that's pretty much as I was expecting. Yeah, to see what happens in the longer term.
Yeah, I intend to stick around to see what happens with this 4th agricultural revolution.